Welcome, everybody. My name is Suresh Srinivasan. I am the coordinator of the Minnesota Astronomical Society's Beginner Special Interest Group. I'm excited. We have Claire Weaverling speaking for our group today. Claire has become, in my mind, one of the best visual people we have in the club. And it's happened very rapidly. I'd say probably over the last, I don't know, 3, 4 years, maybe. She's jumped in and she does a lot of the Astronomical League's visual observing list. Um, that there's probably at least 100 of them now, right? And she has an 18-inch Dobsonian that she primarily uses, and I think she has a smaller scope too. And she's going to do a presentation on a few of the brighter deep sky objects and what to look for and how to find them. So with that, oh, she's also our club secretary, I should mention.
Yeah, right.
It's,
Yep.
right. And when you get the weekly emails for the club's happenings, they come out on Tuesdays. Claire's the one that sends those out. So with that, here's Claire Waverly.
All right. Me and my weird sense of humor, right? Writing the
Yeah,
fun blurbs every week
let
in
me
the
just throw
happenings.
one more comment. If you guys have questions, please drop it in the chat, which is on the bottom of your screen. And then when she comes up, when she pauses, I'll ask the question for you. That way it just keeps the flow going. So with that, all yours, Claire.
All right. Thank you, Suresh. So the title of my presentation today is Sky Sampler, Tasty Targets for New Observers. Suresh, when you asked me what my title should be, I must have been doing this on an empty stomach because I must have had food on the brain. But I think, who's going to object to food and who's going to object to some astronomical eye candy, or what I'm going to talk about as tasty treats today, right? Tasty treats for your eyeballs. All right, so as Suresh said, I'm a visual observer. I do dabble in imaging from time to time, but I'm mostly visual. I joined the MAS actually probably 2011, 2012-ish. So it's been quite a while, but like a lot of people, I was part of the club for a while before I got more active and more engaged. I kind of would, lurk on the outskirts and not be super engaged till maybe around 2015. I think that's when I started meeting more people as part of the club. And like Suresh, you mentioned, I did start off with a 12-inch Orion. So that's what I was using for many years. And then about 5 years ago, the club actually had this 18-inch obsession for sale. And I had what we refer to as aperture fever. And I ended up buying this scope, and this is what I currently use.
Claire, what's the name of your other telescope?
Oh, I know. You want to know because you named it, right? So my smaller 12-inch Dove is called Clairvoyant. That's the little one, and then the bigger one, as you can see, is called Claire Skies. And this is a picture down in Texas. I think Chris Setness is on the call right now. There's a group of us who went down to Texas about 3 years in a row and did some fun observing with the scorpions and the other creepy crawlies in, kind of in nowhere, Texas. Um, all right, so kind of with this presentation, I was thinking back on when I first got started with the club when I was a new observer and I was using my 12-inch Dob. I think, Suresh, you've done it since you've had the BSIG, you've done a really good job of having it be a good learning experience, learning about telescopes, learning about all the equipment, but also like really being in the field and having hands-on experience. I don't remember, like around 2012, I don't think I even really knew the BSIG existed. So my first time bringing my 12-inch Dob out to a star party was out at a public night at ELO. And what I didn't know about setting up your scope out at ELO is that if you set up a telescope, people will come, right? And all of a sudden you'll have kids and families and everybody congregated around you. And I wasn't expecting that. So I all of a sudden I'm like, oh my gosh, I have all these people around my scope. What do I do? I can't remember who was next to me, but the guy next to me was like, okay, just put it on the moon. And I was like, okay, I can handle the moon. So let's get this on the moon. People can look through the eyepiece, they can feel really impressed. And while they're looking at the moon, I can strategize about, okay, what other object as a new observer do I feel comfortable finding? I think the next thing I did was like the ring nebula. I'm like, okay, I can handle the ring. I've been practicing it from my backyard, so let's put it on the ring nebula. Okay, whew. Um, So it went on like this all night long. And I realized the next time I go out to ELO, I want to have my ducks more in a row and be more prepared. Um, but there's, when you get started, there's like a repertoire of objects maybe that are the most common objects for beginners. And so the things I thought of that were probably on my list at that time were the moon is a good one, right? Some of the brighter planets, Jupiter and Saturn, some of the naked eye constellations, right? The Pleiades, the ring and the dumbbell I probably looked at every single time I went out for a very long time, got really comfortable with those. Similarly, M13 and Hercules and Andromeda because it's, bright and I can even see Andromeda from my backyard, even though I'm in Midway in St. Paul. So we all develop like the list of the most common objects to observe. I think at some point though, you want to build your repertoire, right? So how can you challenge yourself to look at different kinds of objects and more objects, and just continue to advance as a visual observer. I think for a lot of us, astronomical league programs, projects are one of the best ways to do that. For me, that was the thing that was most helpful. I started off with the Messier catalog and worked my way through that with my telescope. I also did the binocular Messier at some point. And then another one that Jerry Jones, who's the astronomical league coordinator for our club, he did a presentation on the Caldwell catalog. And after he did that, I'm like, oh, I got to do that one too. So that's like another 110 objects that are really good for beginners. That's a list that was put together by the British popular astronomer Patrick Moore of stuff that's not in the Messier catalog. And then beyond that, there's other lists of objects that you can do. I'm not going to go too much more into depth on that because Jerry Jones did a presentation that's up on YouTube for the BSIG last April, I think, right, Suresh?
Yeah, and just on the side for that, I just put in the chat the link to our club's YouTube channel that
Oh,
does all the
perfect.
presentations.
Yeah. So I think this isn't just a thing for new observers. It's like at any point in your astronomical career, when you find yourself in a rut, like you're looking at the same objects all the time, how can you expand your horizons and challenge yourself in new and different ways? So this presentation today is really oriented toward visual observers, like Suresh said, and also beginning observers. So when you're building your repertoire, how can you keep, like I just said, keep expanding? So what I've done today is put together kind of, I'm calling it a sampler platter of what are the different kinds of objects that you can observe. What are some objects within each of those categories? What are some examples? And then I've picked my examples from going back over my own observing lists and looking for things that I had called out as being particularly great when I was starting out. Like I looked through my lists and found things where I had marked like, wow, or beautiful, or super cool. Or if I didn't write it down in my notes, I just have a memory of like the first time I saw that object. I totally remember that because it left an impression on me. So that's what the sampler platter is derived from. And also I wanted to pick at least a few things in the presentation that weren't just the typical objects that I already described. Hopefully there's a couple objects in here that can stretch you a little bit, or that are a little bit off the beaten path. There may be something that you haven't seen before. All right, so, and then another quick plug, going back to the BSIG YouTube link that Suresh just posted. These are two apps that, if you're not familiar with these, are indispensable as a visual observer. I always have Sky Safari on my phone with me at all times. I tend to use Stellarium more at home on my desktop, but both of these are great tools to have. And there's another YouTube video up there on the BSIG channel that's a tutorial on how to use Stellarium, so definitely check that out. All the images I have in this presentation are all taken from either Sky Safari or Stellarium in terms of how to find objects. All right, so I'm going to start out with stuff that you can do without any equipment, just naked eye. So as a visual observer, one of the most important things you can do is just learning to navigate around the night sky. Learn your constellations. That's important. In addition to constellations, knowing asterisms is also super helpful. And if you're not familiar with the term asterism, an asterism is basically a star pattern, a pattern of stars in the sky that's super famous or well known or very easy to recognize. Oftentimes it's smaller than a constellation, or it can be comprised of patterns that cover multiple constellations, but it's the stuff that you look at the sky and you're like, oh yeah, the Big Dipper, the Little Dipper, the teapot in Sagittarius, if you're familiar with that. In the summertime, there's the triangle that's, moving overhead all summer long. Cygnus the swan kind of looks like a cross. We might call that the Northern Cross. Cassiopeia is my personal favorite because it's a big W in the sky, and my last name is Weaverling. So I appreciate that there's a big W in the sky. I feel partial to that one. But learning asterisms is a really great way to navigate around the night sky and help you star hop to objects. So for the first thing I'm putting on our sampler platter for today is my personal favorite asterism, one that's maybe a little bit less commonly known, but once you see it, you can't unsee it. This is an asterism called Job's Coffin. And this is a picture I took out at JJC one night. Sorry, my cat. Sarah, sit down. My cat's going to walk through the screen here. So this is Job's Coffin asterism. It's pretty synonymous with Delphinus, the constellation, and Delphinus is meant to look like a dolphin. So if you can, hopefully you can see my pointer here, but this is the dolphin, this is Delphinus, and these 4 stars within that are an asterism called Job's Coffin. Sometimes described as being a little lozenge shape. We don't really know where Job's Coffin, where that name comes from, but that's what it's called. 2 of these stars, the Alpha star and the Beta star, are actually the name of an astronomer, a guy named Nicholas Venator. And these 2 stars are basically his name spelled backwards. So if you spell Nicholas backwards, that's Suwalison, and if you spell Venator backward, it's Rotanev. He published that as a joke, but those 2 star names stuck. So now we have kind of 2 joke stars within this asterism, which is another reason why I kind of like it. I like the sense of humor. And then finally, for such a tiny object in the sky, there are quite a few deep sky objects. There's no Messier, but there's a couple galaxies, a couple globular clusters, a couple planetary nebula. There's also a really fun open cluster there called the Toadstool. I didn't put that on our list. It's a little more challenging. But so there's a lot going on in quite a small area of space. And you can find this. Okay, so back to asterisms, right? Here's our night sky. And if you're looking south in the summertime, here's the Milky Way. You can see Sagittarius, the teapot, and over here is Scorpius, the scorpion. And if you go just up the Milky Way, here's the base of the summer triangle. Okay, sorry, my cat is trying to come into picture here. Bud, sit down. Here's the base of the summer triangle. The top of the triangle is kind of cut off in this picture, but if you look just over to the side, there's Job's Coffin or the dolphin. They're not super bright stars, but again, like I said, it's a very recognizable pattern in the sky. All right.
We just pause for a second and ask, anybody have any questions so far? Any comments? I don't see anything in the chat just yet. I just thought I'd ask. I guess not. Back to you.
Okay. All right. The second asterism that I'm going to recommend that I have on my sampler platter is another favorite. Whereas Job's Coffin is a naked eye asterism, This one you need binoculars for. It was actually discovered by an amateur astronomer using binoculars. And this is an asterism called Kemble's Cascade, and it's in the constellation Camelopardalis. If you know me, you know that I really love the constellation Camelopardalis, and the reason I really love it is because it's basically a big blank area of the sky that doesn't look like anything. You might have to sit out in your lawn chair and look up at the sky for about 20 to 30 minutes and get your eyes dark adapted to even see any stars at all in the constellation. So you wouldn't expect to find such a visual gem in this kind of obscure area of the sky. But thankfully, it's neighboring a couple other more well-known constellations. So it's completely doable for new observers. So looking at our sky here, we talked about the W. There's the W asterism in Cassiopeia. And here's Perseus right here. And right here is the constellation Camelopardalis. And if you star hop either down from Cassiopeia or over from Perseus, you'll find this really lovely chain of about 20 to 30 fifth to 10th magnitude stars. I'm going to go back here because this chain of stars does also culminate in another open cluster. This is NGC, let me get this NGC number right, 1502, I think, yeah, NGC 1502. And this is a 6.9 magnitude open cluster. So if you're able to get this, again, you want to have maybe binoculars or a small telescope with a wide field view, because this is about 2.5 to 3 degrees down the sky. But this is quite a lovely object to observe. So it's well worth, it's a big payoff in a kind of blank area of the sky.
Yeah, it's a great one for binoculars. I've seen that from dark skies.
Right.
Like you said, right in the middle of nowhere.
Mm-hmm. Okay, so get to know your asterisms, discover some beautiful asterisms. So those are the two that I'd like. This is just a sampler, right? Sampler platter. But those are two that I would add to your list if you haven't paid attention to those before. The next thing I wanted to add to my sampler platter for beginning observers is a handful of double stars. And what I wanted to say about double stars is I don't know if this is true for other visual observers, but when I first started out, I went right to deep sky objects because I thought that those were more glamorous. I wanted to see a galaxy or I wanted to see a planetary nebula or something like that. I was like, even though it's astronomy and we're talking about stars, I was like, meh, stars. I'd probably seen, this is a famous double star pair in the handle of the Big Dipper, Mizar and Alcor. I'd probably seen this before just because it was so famous and looked at it and said, yep, okay, there's two stars there, sounds good. And then not really given double stars more thought than that. But then recently, because I'm working my way toward master observer status, and the double stars list is one of the required projects to become a master observer. So I'm like, well, I got to do my double stars. So I started working on these, and lo and behold, I discovered that some of these double stars are, when I look at my log sheets, I have them described as like very beautiful or stunning or striking, right? So some of these are quite lovely and well worth your time. I've chosen 3 to put on the sampler platter. A lot of double stars, again, when I look back at my log sheet, a lot of double stars I have listed as, I think I call them like vampire bites. They just look like 2 white little identical stars pricking their way through the black background. And they're kind of cool, but that's more like vampire bite stars. But the ones that I'm highlighting today, I think what's so striking about them is the double stars that have great contrast in terms of different colors and different sizes and brightnesses. That's what makes them so stunning when you see the 2 stars together. So the first one I wanted to highlight was a double star called Alberio. This is in Cygnus. This is the beta stars in Cygnus. This is probably one of the most famous ones because people consider it so beautiful. So if you look at it naked eye, it will look like a single star, but if you put a small scope on it, or even binoculars, it will be revealed to be two stars. It's actually, a lot of these stars are actually multiple star systems rather than two, but typically from our vantage point here on Earth with the equipment that we have, we can split, two stars of the group. So if you look at this one, you'll see a golden yellow star and a second star that's a sapphire blue or even a cyan color. So this is a really beautiful one. And also some double stars are true double stars, meaning they're part of a star system. And some double stars are just optical doubles, but it's just the stars are not gravitationally connected to each other. It's just from our vantage point that they look like a double star. And this happens to be one of the ones that's not a true double star. It's an optical double.
Let me just jump in just for a second on that,
Yeah.
Claire. So at the BSIG observing sessions that we do when it's warm, I typically will point out Alberio through my telescope just
Oh, good.
because
Yeah.
a lot of people will say they can't, there's no color in space, they can't see color. And then you point at Alberio and those
Yes.
are obviously two different colors.
Yes.
So that's
Right.
for beginners, that's a great one to start with to gauge different colors in the sky.
Yeah. And this one, so we talked about our asterisms, right? So here's the aster. Now you can see the full summer triangle, right? So Denna, Vega, Altair, not quite in the middle, but kind of in the middle. Here's where you can find Alberio. So it's totally findable. This one is sometimes compared to Alberio. This is another one that has that great color contrast to it. So this is Almach, or this is the gamma star in Andromeda. And again, this one is sometimes nicknamed the Easter egg double. And the reason it's called that is, like I just mentioned, you look at it naked eye, it looks like a singular white star, but you look at it through a small telescope and it's like the color gets revealed to you, right? I describe this one as very striking in my observing notes. And so again, this is actually a multiple star system. I think it's the A component is actually a quadruple star. But from our vantage point, it will appear as two stars that you can split. And again, this is a yellowish star with a blue or sometimes emerald looking companion star. And this one, so here's Cassiopeia again, there's the W and there's Perseus. And we just saw appears the great star of Pegasus in Andromeda. And if you just follow the line of stars down from Andromeda, that's where you can find this one. And just one more that I wanted to highlight. This one is, I don't even know how to pronounce this, Suresh, Achird.
Yeah, I just say I cheered.
Achird, yeah. So the Eta star in Cassiopeia. This one doesn't have quite the color contrast. This is a smaller, fainter orange red dwarf star with a yellow white star. But there's a difference in sort of size and brightness of one of the stars. So it's very visually striking for that way, for that reason. And this one is also cool because the A star of this pair is a twin of our sun. So it's older than our sun, but it's almost the exact same mass and radius as our own sun. And this one can be found right in Cassiopeia, the W. So if you can find these two stars of the W, that one's kind of right in the middle and just a little bit off of that. All right, so get out there, observe some double stars. Don't neglect them the way that I did when I was a new observer. So after double stars, the next thing I wanted to put on the sampler platter of objects are some open clusters. So we talked about double stars being multiple star systems. Now we're talking about objects that are, hundreds or thousands of stars clustered together that make up some of the most beautiful patterns in the night sky. Some famous ones that I'm not going to focus on today, but you may be familiar with the Pleiades, right? That's a super famous one, sometimes called the Seven Sisters. Looks like a kind of a little teeny tiny scoop, I always think, in the night sky. There's also the butterfly cluster, or the Ptolemy's cluster. Those are some that you may or may not have seen out at the BSIG. I wanted to take a second, though, to talk about what an open cluster is. So open clusters are right in our galaxy, and they're stars that are typically, I think of as like brother stars or sister stars, a group of stars that have been born together in the same stellar nursery, and they've kind of moved off together into space, and they're still gravitationally bound with each other. They're not baby stars, they're maybe like teenage stars, but they're still considered really young stars that are traveling together through space. And like I said, comprising these really beautiful patterns of stars from our vantage point. At some point in the very far distant future, they'll probably wander off from each other, as teenagers do. But for right now, we can still enjoy these amazing patterns in the sky. And so the couple that I've picked for today that I'm particularly fond of and that I remember really enjoying as a new observer, the first one is the double cluster in Perseus. I was observing this one even before I ever got a telescope. I think this is one of the very first objects that I started looking at through my binoculars. And this is a really beautiful one. What's nice about it is there's two clusters together, and they actually are just a few hundred light years from each other. We are in the Orion spur of our Milky Way galaxy, and these clusters are in the Perseus arm of the Milky Way. So when you're looking at them, you're looking from the Orion spur into the Perseus arm of our own galaxy. They also have some nice color contrast, and they're very rich. So astronomers classify open clusters in several different ways, but one of the ways that they classify them are very star rich or very poor or somewhere in the middle. These open clusters are considered very star rich, with each cluster having at least 300 stars in it. And then, like I said, some red supergiants among some of the blue-white stars that gives them a nice color contrast. So when you look at these with binoculars or with a small telescope, it's just a very rich visual experience.
Let me pause yours for a second. Does anybody have any questions or comments for Claire? I don't see anything in the chat, but feel free to speak up. All right, back to you, Claire.
All right, and so again, going back to our night sky and some of the astros, and here's the W, right? And here's Perseus again. And down here you can see some of the winter constellations. There's Capella and Auriga. There's the Taurus, the bull. And right here between Cassiopeia and Perseus, kind of right between those two, if you pass over that with your binoculars, that's where you'll find the double. I always like that one too, because again, as a new observer, it was easy for me to go out into my backyard and find that one. All right, this is another favorite that I remember. I actually was looking at this one last summer because I hadn't looked at it in years, and I really needed some eye candy, right? So I'm like, oh, I'm gonna look at the owl because it's just so beautiful. This one is in the Caldwell catalog. Some people, I always refer to it as the owl. Some people might refer to it as ET. I think I've also heard it or seen it referenced as the dragonfly. Some people say ET, some people say owl. It's nice because it actually looks like the name of the open cluster. It really truly looks like an owl or like ET, You can see here's the body and the eyes and kind of the arms or the wings, right? This one really stands out from the background. And like I mentioned in the other one, it has some really nice color contrast in there. It's also considered a rich cluster. The stars are young. I didn't really mention the ages, but the stars in this cluster are about 21 million years old, which sounds old, but in astronomical terms is actually quite young for stars. And astronomers think that this is mostly a true cluster. Most of these background stars here are part of the cluster, but the eyes are thought to not be part of the cluster. Rather, they're stars that are between us and the open cluster. Kind of even looks like that in the picture, right? The two eyes are somewhere between us and the cluster. So not true members of the cluster, but I think that gives it really interesting visual depth. This one is also very easily findable for beginners, just off of one of the stars in the W of Cassiopeia, right there. All right, and then I mentioned at the beginning you may have seen the double, you may have seen the owl, but I wanted to showcase at least a few objects that were a little bit off the beaten path, maybe not as commonly observed. And so Caroline's Rose is another open cluster that's really pretty that I wanted to showcase. This one is NGC 7789. It's not in Messier and it's not in Caldwell, so it's just an NGC object, but it was discovered by the astronomer Carolyn Herschel back in 1783. It's considered very visually beautiful because it's got these patterns of stars with some dark lanes there, so that when you observe it, it really does look like the petals of a rose viewed through the telescope. And so I mentioned 21 million years old for the owl. This one actually has stars that are 1.6 to 1.7 billion years old. So for an open cluster, it's regarded as having older stars than a lot of other open clusters. And because it's that old, many of its more massive stars have already evolved into the orange giant stage. There's also some blue stragglers in there. So again, that's part of what gives it interesting color contrast. And again, we're back to Cassiopeia the W. This is another one that you can just easily star hop to from Cassiopeia. All right, so we've got some double stars, we've got some open clusters. The other kind of star cluster that I want to add to your sampler platter for today, and that is also a popular observing target for astronomers, is a star cluster called a globular cluster. So open clusters are some of the youngest stars, teenage stars, as I mentioned. Globular clusters are at completely the other end of the spectrum of stars. Some of these stars represent the oldest stars in not only in our galaxy, but in the universe. So going back almost to the Big Bang. And essentially what a globular cluster is a compact ball of these old stars that don't actually reside in the plane of our galaxy. They reside outside the plane of our galaxy in what astronomers refer to as the halo. And they're typically concentrated toward the galactic center, although you'll find some globulars that are kind of off in the halo away from the galactic center. I always think of globular clusters. The image that always comes to mind for me is a dandelion in the summertime when it goes to seed and it sort of scatters off. I think globulars have that, like the head of the dandelion kind of look to them. And some really famous ones that you might, if you're out at the BSIG in the summertime, right, you might have seen M13, which is the great globular cluster in Hercules. If you're looking south in the summertime in Scorpius, right off the bright star Antares, you might have seen Messier 4. I threw in here Omega Centauri. This is not one that you can see from Minnesota, but a lot of us have had the opportunity to travel south to Oklahoma or Texas or somewhere where this is the largest globular cluster that you can view. And it's quite amazing. I've been able to experience it, I think 3 or 4 times. And if you have the opportunity to travel south, that's another really great one. So the ones that I wanted to showcase though today, I mentioned some globulars being a little bit further out from the galactic center. When I was looking back over my log sheets, every single time I have viewed M2, I have always written something like, wow, amazing. I think one of my notes was like, now that's a glob, right? And I'm like, well, okay, why do I always like that one so much, even more than M13? And I think the reason is, again, this is a fairly dense globular. So with globulars, astronomers classify them by how dense they are or how loose they are on a scale of 1 to 12. This is a 2, so it's fairly densely packed. It's fairly bright, but because it's off by itself in a part of the sky that's a little bit more remote and sparse, I just find that visually striking. So I think that's my hypothesis about why every time I observe M2, I always have some exclamation in my notes about why I think it looks so cool.
Can I add something to that, Claire?
Yeah.
So M2 is one of my favorite globulars in the whole
Okay,
sky.
you're with
And
me, right?
yeah, totally. And one of the reasons is because nobody else has it on their top list. It's because it's so remote, it's in the middle of nowhere, that it's hardly looked at compared to some of the other famous globulars
Right.
in that part of the sky. I'm thinking M3, M5, M4,
Oh, I got
M13,
those in here too. I'm
M92.
going to talk about those.
Yeah.
Right. Yeah.
But this one is, I mean, this one really stands out. Like you said, because it's in the sparse sky, it really is striking.
Yep.
So, and what you're looking at here is probably 250,000 stars in a ball, in a single ball. I call them star cities because that's what they look like through a telescope.
Yep. Okay. Yeah. So this is the top of my list. This was my number one. So it's good to hear that I'm not alone in that. Right. Um, so this one I have that it's got 150,000 stars in it. 13 billion years old. So close to the beginning of our universe. And a class 2, so very densely packed. Um, just a couple random things about this globular to add to the coolness of it. It's hypothesized to be the remnant of a dwarf galaxy. So a dwarf galaxy that our galaxy collided with way back in time. And we picked up these stars from that other galaxy. Also, M2 is thought to have a tidal stream. So sometimes when globulars get perturbed by something else gravitationally, they can shed some stars and have what astronomers call a tidal stream. And so M2's got a tidal stream that's thought to be because it was perturbed by the large gravity from the large Magellanic Cloud. So that's another cool thing about it. So Suresh, you mentioned M3 and M5. I did add those for comparison here. So Messier 3, right? This is another really old one, about 13 billion years old. This is a class 6, so a little bit looser, not as dense as M2. And this one also sits out there far from the galactic center. The reason I picked this one is because this one is sometimes referred to as the herald of globular cluster season. So globular cluster season is right from like spring through the end of the summer, kind of fall, when you can see all the globulars toward that galactic center. But because this one is so far over here, like here, I kind of have it cut off in this image, but here's the Milky Way coming down here. And this is kind of way over in this direction where it comes up during globular season. At the beginning, it comes up much earlier in the evening than the rest of the globulars. So it's sometimes referred to as the herald of globular summertime. And then finally, M5. Um, this is one that's got just a really beautiful kind of, some people say spider legs, but I think in my notes, I referred to it as almost like a galaxy feel, like it's got kind of a swirl or a spiral pattern that can remind you of like a face-on galaxy, even though it's a globular cluster. And this one was described, I actually discovered that E. E. Barnard, the famous astronomer, he famously said that this one was more beautiful than M13 in his opinion. Um, so again, maybe it's that galaxy look and feel to it. This is a class 5, so somewhere in the middle in terms of density. And again, this one is not quite as far over as M2, but still here's Scorpius and here's the Milky Way over here, right? So quite a ways off of the galactic center. So definitely go out there and observe some globular clusters. The thing I would say about globulars too is that I did do the globular program, Astronomical League observing program, where I observed 50 globulars from, I think I started in April and ended in August. And they can be kind of hard to detect when you're first looking for them, when you don't know what you're looking for. But if you get practiced enough, it's almost like you can get a sort of feel for, like they pop right out when you sort of know what you're looking for. So it does get better with practice. All right, so after star clusters, I wanted to throw a couple planetary nebula on your sampler platter. So like I mentioned, for me, looking at the ring and the dumbbell, I probably looked at those like a gazillion times when I was starting out, and I had never looked at any other planetary nebula for quite a while. I think at some point, I looked at like the cat's eye, the clown face, and the helix because those were on either like on the Caldwell list, I think. So I ended up looking at those. Um, the two, and I don't know, maybe you'll disagree, Suresh, but I was trying to think of like of the planetary nebula that, you know, are typically on those lists. After you've done the ring and you've done the dumbbell, maybe what would be the next one to try? Planetary nebula can be a little bit tricky. They can kind of look like little fuzzy stars or look a bit like stars. And so practicing, passing your telescope, finding it, and then distinguishing it from the stars around it can be tricky. So here's a couple that I had in my list. Trying to see how I had described these. I think so for this blue snowball, I should start with what is a planetary nebula. So a planetary nebula is a glowing shell of gas that's been expelled by a dying star. And these shells of gas can have different shapes, like the ring shape or the dumbbell shape or a cocoon shape or like, what looks like a cat's eye shape. So for this one, for the blue snowball, I described this in my observing notes as a greenish circular glowing disc. And I had thought that using a little bit of averted vision, I thought that I could see the central star kind of pop in and out if I would wiggle my eyeball a little bit. But this was one that I really liked and that you could practice with. And then the other one, so this one is located, here's Andromeda, here's the Great Square of Pegasus, here's Cassiopeia, here's our Milky Way, and then the blue snowball is right there. And then the Ghost of Jupiter is another one that I had called out in my observing logs as having really liked. To me, this had looked like a very bright round or a very bright fuzzy circle with a distinct green blue color to it. And this one is actually named Ghost of Jupiter because it does have that kind of planet-like shape and feel to it. It's got a high surface brightness and this clear disc-like or planet-like shape to it. And that one is located, this one's a little bit further to the horizon. So here's Virgo, here's Leo, and then here's Hydra. And so right there, star hopping down from one of the stars in Hydra is the ghost of Jupiter. Suresh, anything you want to add about trying to take a stab at planetaries and finding them and recognizing them?
It's funny. I was thinking through this as you were saying this. So for me, the ones I would add are NGC 40 in
Mm-hmm.
Cepheus, the Eskimo Nebula in
I,
Gemini NGC 2392, and then the Cat's Eye 6543. Those are
so
the
those
three
are
that
ones
I
that
would.
I was, yeah, debating. I was trying to remember like in terms of level of difficulty, right? So the Eskimo, Cat's Eye. Would you say those are easier, more
Yeah, I would say
difficult?
so. Just because they're brighter, I think.
Yeah.
And they seem to stand out. And obviously the Helix, because it's enormous.
Hmm.
That's one you can get in binoculars, in the
Yeah.
dark sky.
Yep.
So it's almost naked eye.
Yep. So yeah, this is my list that I was debating on which to feature, right? So of any of
Hmm.
those, give them a try, right?
Yeah, no, it's a great list.
Sorry, I have my cat walking over my keyboard again.
The Cat
Uh,
Nebula.
the cat's eye nebula. Oh, you said his timing was perfect, right? We said have the cat walk
He's
through
good.
right when we're talking about the cat's eye.
Exactly. Does anybody have any questions while we're paused here, Claire? Any comments? Anything? Kind of a quiet crowd.
It's cold, right? People's
It's cold. Everybody's cold. All right, go ahead.
okay. So after trying your hand at planetaries, the next thing I wanted to add to the sampler platter was trying your hand at some, also called nebula, but not the same object. So in this case, we're talking about, like if we're talking about the Orion Nebula, a big star forming region within our own galaxy, or what we might call like a stellar nursery. Hey, so a big nebula of ionized gas and dust that glows due to the intense radiation from the young baby stars that are within the nebula. Um, I'm not going to showcase these because I think if you haven't seen any of these, definitely add them to your list. If it's winter time, the Orion Nebula is probably hands down the easiest to find, one of the most beautiful things you'll look at, um, and definitely a must see. If it's in the summertime and you're looking south toward Sagittarius, you'll want to check out the lagoon and the Trifid, which are, near each other and doable together. Those are great ones. I thought about showcasing the rosette, but I think the rosette is kind of hard. The star pattern inside the rosette is findable, but seeing the nebulosity can be really tricky. Um, so put those on your list, but the one I wanted to showcase today is Messier 17, sometimes called the Omega or the Swan. I just went back and looked at this one again last summer because I said I needed some eye candy, and I hadn't looked at this one in a while, and I really like it. So I think it's also called I haven't heard it called all these names, but on the internet it said horseshoe, lobster, checkmark, or tobacco pipe. Those are some other,
Had a
there's a
lot
lot
of
of names,
names.
right? I think I always say Swan or Omega. So, yep. So this is a large and bright star forming region within our own galaxy that's about 5,000 to 6,000 light years away from us. Um, and yeah, this is a really beautiful one. I'd say like slightly more challenging than the lagoon and the Trifid. So like after you've tried those, maybe this is in the same region of the sky. So maybe try this one next. And this one, so when we were talking about those globulars, being way out here somewhere, now we're talking about I describe this is like 494 at rush hour, right? So now you're in the part of the sky that's very cluttered and a lot of stuff going on that can make it a little bit trickier to find, but it's also good practice finding things right in the Milky Way. You've got the good fortune of having the Sagittarius asterism nearby, so star hopping up from that is a good technique. All right, and then the very last thing on our sampler platter today to feature are some galaxies. I tried to put these in order of like easiest, with the asterisms and some of the double stars to things that are more difficult to find, some of the deep sky objects like a planetary nebula or a galaxy. Some starter galaxies that you might already have looked at or you might want to add to your list. Andromeda, I think I mentioned at the beginning that I can even see this one from my very light polluted backyard in St. Paul. So that's a great one to start with because it's bright. Whirlpool is another one, a face-on spiral galaxy that's a popular target for amateur astronomers. I think actually before Andromeda, the very first galaxies that I saw for the first time were M81 and M82. So that's those are in Ursa Major. You can get two in a view with those. So those are good starter galaxies. I'm going to feature three other ones in addition to those. So I put Triangulum on the list. And the reason for that was it's in the same vicinity as Andromeda, so not too far away, but slightly more challenging, not as bright. So it's a good challenge object if you've already seen Andromeda. Also, Milky Way, Andromeda, and Triangulum are all part of our local galaxy group. So it's fun to see another galaxy that's that's one of our own companion galaxies. And like how they rank in terms of Andromeda is the biggest, and then Milky Way, and then Triangulum is smaller than both of those. But Triangulum, so when I was looking it up, it's described as a hotbed of starbirth, right, with a star formation rate that's nearly 10 times higher than the Andromeda galaxy. But just to give you a size comparison, the Milky Way is estimated to have 200 to 400 billion stars, and Triangulum is estimated to have around 40 billion stars. So more star formation, but smaller.
Claire, can I add something to that?
Yeah, go for it.
So those reddish areas there are the star forming regions, right? So the one on the bottom there, the brightest one on the bottom, nope,
That
to the
one, this
left,
one.
that one. That's NGC 604. That one is 100 times larger than the Orion Nebula. It's one of the largest
Just
ones known.
crazy, right?
It's 1,500 light years across, and we're seeing it from about 3 million light years away. And this galaxy can be sometimes hard to find, especially from the city because its light's spread out. The easier way for me to find this thing is to find that NGC 604, and then from there I can key on it and get to the core of the galaxy. But
Can you
it's that
imagine
bright.
being on a planet in a solar system somewhere there where you're looking at that in your night sky?
It would cover the sky, basically. It'd be 100 times bigger than the Orion Nebula.
That would be craziness, right? So like Suresh said, right, this is, here's Andromeda's here, little triangulum is here, and this galaxy is located right there. Yeah, I would recommend like Andromeda you can do in your backyard. I don't do this one from my backyard. I'd recommend getting out to a darker sky. Right? Okay, then the next one I wanted to showcase, because I have a funny story behind this one. So when I was first starting out with my 12-inch and I was up north, just outside the Boundary Waters, in January, it was super cold and I had very dark pristine skies, but somewhat there was a lot of tree cover, right? So I was waiting for things to come past the trees. So I waited up hours in the cold to see the two Messier Leo galaxies. I observed them. I found them and observed them for the first time in these pristine skies. And I was so proud of myself. And I didn't know it was a triple though. So sometime later, I heard somebody mention the Leo triplet. And I was like, oh, there's a triplet in Leo. And I looked it up and realized that I had seen the two Messier galaxies, but the NGC galaxy I had completely neglected because I didn't know it was a triplet. Um, it's fainter though than, so these are the two Messier galaxies are M65 and M66. And this, what's sometimes called the hamburger galaxy, is fainter than those two. But you can get three in a view if you're able to under dark skies. And so that's a popular object and definitely worth it. But don't forget the hamburger if you're able to see that one. So these are a small group of actually spiral galaxies that are interacting with one another. And yeah, I don't know. Suresh, do you want to add anything about finding the Leo triplet?
Um, it's easy to find. It's right. So that area just above where Claire's cursor is called the hindquarters of Leo. Those three stars there, the back end of the lion. And so once you find those stars, you could just star hop to those galaxies. And from a dark sky, you can even pick them up in your finder scope, which I've always thought was kind of cool for galaxies that are, I think, like 20 million light years away or so, maybe even further.
These are, let me see if I have that. Oh, I think I have it here. So 35 million light years away.
Or 35 million, yeah.
Mm-hmm.
And you can see them in your finder scope. That's how bright these are.
Mm-hmm. I'm not an imager, but I did image these because I only had a 200 millimeter zoom. They were like little teeny tiny in my image, but I did manage to image them. So
Can you go back to that earlier image you had of them? So do you want to talk about that tidal tail that stretches down? Do you see it?
yeah.
You want go for it if you know what that is.
So yeah, so this is a massive tidal tail of stars stretching nearly 300,000 light years. It's caused by
Mhm.
gravitational tugs from the other two galaxies, is my understanding of it.
Yep.
Yep.
It's pretty amazing to see that from 35 million light years away that this tail is hanging out from this galaxy, on your images.
And obviously it's called a hammer because it does kind of look like a hammer with buns and meat in the middle, right? Does it have other nicknames? Do you know, Suresh?
No, I call it the hamburger,
Yeah.
because it does look like a hamburger.
All right.
Maybe sausage. I don't
And
know.
right. All right. And then I've got one more object on our sampler platter, and then we can wrap up. So the last one is another one that every time I've observed it, looking back in my logs, I've always found it to be really impressive. So there's that. And the other reason I wanted to add it to the list is it's a galaxy in Virgo that for me was more doable before I did like the Virgo venture or some of the other Virgo objects. So for those of you who are new to the club, there's an event that happens every spring called the Virgo Venture. And we talk about star hopping, right? Where you hop from one star to another to find something. In this case, you're actually galaxy hopping from one Virgo galaxy to the other and logging them, right? I think people have different techniques, right? So you can make yourself a little map or make yourself a little cheat sheet so you can follow along with which galaxy is which. It can be very challenging to do. I know the first time I tried to follow some of the Virgo galaxies, I just lost track of which one I was on. But I think the sombrero is probably a good starter galaxy in Virgo to look at. It's very distinct. And it's pretty cool looking. Let's see. So yeah, it's about 30 million light years from Earth. It is one of the most famous and frequently photographed objects in the night sky, because it does kind of look like a sombrero. It's seen edge on from our vantage point. It's about 50,000 light years across and about 1/3 to half the size of the Milky Way.
Yeah. So one cool thing about these galaxies is some of them we see edge on like that one, and other ones we see more face on like the Triangulum galaxy. The one that I like, Claire, that edge on is at NGC 6545. Did I say that
Mm-hmm.
right? No, 4565. 4565 in Coma. That one's huge. It's like 3 times bigger than Sombrero. And I don't know how it missed being on the Messier list. I don't know how he missed
Right?
that.
Okay.
And it's super easy to find. So that'd be
Mm-hmm.
one I would add for
Okay.
sure.
Well, we have this on the recording, right? So even though I don't
Yep.
have that in the PowerPoint, people can catch that from the YouTube.
Yep.
All right. So yeah, here's Virgo. Here's Corvus and Crater, right? And just up from there is the sombrero. So I did put these on a sheet. I didn't really talk about like what time of the year to see these, but I did. You can grab this if you want to keep the list. Add some others that we've talked about today to this list. But here's kind of the best times of year to see most of these objects. And then this gives you a variety of a couple different kinds of objects that you can try finding in each season of the year. Try
Yeah,
try
maybe give
try
people a
the
chance to.
sampler, right? Go ahead.
I was gonna
Sure.
say give people a second to maybe snip that chart on their screens if they
Yeah.
want. And while they're doing that, Jim Peasley mentions Mizar is itself a double star. It can be split as low as 48x magnification.
If you have good eyes, right?
The thing about Elkhorn Miser is ancient civilizations knew about them, obviously. And if you couldn't split Elkhorn Miser, you could not be in the Turkish army back
Oh,
then,
for real?
about
Okay.
500 years ago. Yeah, so
Yeah.
it was a check
It's
for
an eye test.
eye test.
Some of
Yeah.
us already failed the eye test. I know Chris is on this call too. Some of us have eyeglass issues with our doing all the stuff
I
you
guess you
need to
couldn't
do
you
as an
you couldn't
astronomer with eye issues.
I guess you couldn't fight in the Turkish army then.
Probably not. No.
Does anybody have any questions for Claire? Any comments?
Hopefully this gave you enough of a kind of the different kinds of objects that are out there and a couple examples, not the only examples, but just a little inspiration, right? Obviously, everybody has different taste kind of in what you like to observe. But like
Yeah.
I said at the beginning, it's always good to challenge yourself to observe some different things that you haven't seen before.
Yeah. Zenobia adds that she's a big novice, but man, this was a great presentation. I appreciate your sharing your passion, Claire. And the kitty was voicing its approval through the whole
Did you?
presentation. That was
I didn't know
great.
if you guys could hear. He yowls all day long. Sometimes when I'm on the computer, I start to tune it out after a while.
Yeah, she said that she really appreciates the location finder.
Oh, good. Yeah.
So Fred is putting his thumbs up. Does anybody have any other questions for Claire? This is great, Claire. Thanks for doing this.
Yeah. Well, I'm wishing all of us clear skies this year, no wildfire smoke, perfect
Yep,
weather for the BSIG every time,
every
right?
time. And don't forget, there's a Messier Marathon that the club does too in March.
Right. Yeah, I
So,
forgot to mention
so,
that.
so there's the Messier list, as Claire had mentioned at the beginning, is 110 of the best sky objects, deep sky objects, and by a quirk of orbital geometry, in about mid to late March, you can actually see all of them in a single night. It's kind of weird. The sun is just in a spot part in the sky where there are no Messier objects. So all the other Messier objects are actually visible. So it's not easy to do 110 objects in a night, but it can be done. But even if you get 30 or 40, that's a great night. So So in addition to the Virgo venture, we also have the Messier Marathon coming up.
And the mini Messier too, right? If you don't want to do
Mini
the full
Messier
Messier.
in,
Okay.
I think the mini Messier is in what, September?
I think
Chris,
so, right, Chris?
was Chris on here?
He is. I don't know if he's unmuted.
Yeah, I think it's like early fall. So yeah. Oh, Chris is saying it's in the fall.
Yeah.
All
And
right.
any other and any other, no, I think we covered all the major viewing nights, right? The Virgo, the Messier,
Yeah,
the
we do have, or if we,
uh,
so our club does do an annual star party up at Long Lake Conservation
mhm,
Center called Northern Night Star Fest. And that's under really, really dark skies, about 2.5 hours north of the Twin Cities. And it's kind of a fun, I think, was it 4 days, 5 days, 4 nights, something like that.
mhm,
And it's just a lot of fun. So, and that this year is in mid-September if people are interested in coming. But if you're into observing or even imaging, it's a great way to get away for a few days under really dark skies. September usually there's less smoke in the air. It's just a really good time. So consider that too.
and Long Lake now has there's like every month, right? At least one member night each month, if not more
Yeah, we
than that.
have I think 2 weekends a month. We
Yeah.
have starting from like April through like into early November, I think.
Hmm.
Usually these are around new moon weekends, and we can stay up there for free. And we get to use the field, the observing field. So it's really a nice setup for us. All right, Claire, thank you
All
again.
right. Yeah.
Very,
Thank you, everyone.
really
Clear
appreciate you
skies.
doing this.
Good
Just
luck.
a little plug. Uh, thanks. A little plug. So the next BSIG presentation will be on Saturday, February 21st. I will be presenting all about telescopes. So it's a kind of a deep dive into the various kinds of telescopes, the good and bad of each kind of telescope, which you might want to consider if you're looking for a telescope. So if you have questions, bring them to that talk. Last time I did this several years ago, it was over 2 hours. A lot of questions. So I'm gonna try to pare it down from there. But yeah, so the next one is coming up on February 21st, and I hope you can join us then. As you know, this was being recorded and it'll be posted onto our MAS YouTube channel in a couple days. So what if you want to watch it again, or if you only caught part of it, you can catch it again. So with that, I will say thank you, Claire,
All
and we'll
right.
see you guys next time.
Stay warm, everyone.
Yeah, stay warm. Take care. See you next
All
month.
right. See ya. Bye.